All right. Hello, everyone. Welcome to the wasmCloud Wednesday community stream on Wednesday, March 29th. We've got a pretty fun agenda today. Should be a lot of great discussion. I'm going to go ahead and start off just by sharing. You know what? I'm going to go ahead and share my whole screen because I'm going to need to do that anyways. So go ahead and get some stuff moved around. So here is the agenda for today. This is still kind of in our staging environment, so we're going to merge all this into the main website here shortly after the meeting. But I actually have a demo for you of a similar example to wasmCloud's KV counter, but using WebAssembly components and running in version 62 of the wasmCloud host. We're going to have a long discussion on the implications of what components mean for the wasmCloud ecosystem. And I've kind of broken this out into a couple of different sections to encourage discussion around actors, capability providers, language support, all of those things. But this should be a pretty fun discussion. Please feel free to jump in and ask questions. And then after that, Kevin is going to give a demo of Cosmonic's latest open source project, Concordance, which is an open source framework for building event source systems with wasmCloud. So super excited for that. Without further ado, I'll go ahead and get started. So not everybody was lucky enough to go to the wasm.io conference last week. Time is weird, including myself was unfortunately not able to go. And so I didn't get to see Bailey's super awesome demo where she showed WebAssembly components working in wasmCloud. And so I want to bring that super fun demo to you today. So just to give you an idea of what this looks like from the wasmCloud perspective, WebAssembly components are mainly going to impact actors in the short term. And the way that this works is when you're running WebAssembly modules within wasmCloud, you are essentially creating one bit or this bundle of a WebAssembly module that includes on both ends our framework called WasmBus RPC. This is how we kind of do type translation, serialization, and so that when you actually program your actor, you're doing it in terms of the common contracts for key value or for messaging or things like that. Now, the WebAssembly component model, and I'll touch pretty briefly on this. I'd be happy to answer a couple of questions, but essentially all of these common contracts with the WebAssembly component model, this allows you to compose different WebAssembly modules together with a common interface to talk between them, including like interface types, more than just numbers. And you can actually compose these WebAssembly modules into a single WebAssembly module we've been calling a fused component to actually form your application. So what this currently looks like is you're taking wasmCloud specific interfaces for HTTP server and for key value. And even though those are just types and serialization, you're still kind of bundling that into your WebAssembly module. So it's very wasmCloud specific. The way that this will work and this is, labeled future, mostly just because, not that it's there, just because actually getting the formal support for stability, like in WASI Preview 2, is going to take just a little bit longer. The way that this is going to work is you would have a different WebAssembly components based on the wasmCloud interfaces, very similar to wasmCloud interfaces. It's just contributed to the standard and implemented in the WebAssembly system interface standard. So we have HTTP server.wasm, which implements those common types for an HTTP server, key value.wasm, and then we would actually provide, something like a wasm bus sender that does the translation for wasmCloud so that we can send your request off onto the lattice. It can be handled by any component on any system, all the things we do for distributed. And then the actual piece of logic that you would write would just be the small KV counter WebAssembly module. So the way that this works with the WebAssembly component model, the real cool thing is that you actually do just get to write your piece of business logic. And then you do that in terms of the common wasmCloud contracts. And those can be implemented by any number of runtimes. So you're not actually tying yourself specifically to wasmCloud specific interfaces. And so the big effect of that is that you could write a WebAssembly module somewhere else, see the need to make that distributed or want to run it in wasmCloud, and you can just bring that right in. Now, I want to show you kind of a concrete example of what this works with. I'm actually just going to be following some of the steps that Bailey did for her demo. And I'm going to kind of stitch together an actor, a wasmCloud actor, but with the WebAssembly component model. So I'm working out of her repository, the wasm.io 2023. I don't have a link to it now, but we might be able to get that here in the Zoom chat. If I go over to the, let's see, where am I right now? So I'm just in a little demo directory. If I go in here and go into the ping pong directory, this is the actual development of a WebAssembly component called ping pong. It takes a message in over a NATS message bus, or it takes a message in over the messaging wasmCloud contract, and then interacts with a key value store using the WASI key value contract. The code here is, of course, likely to change. This is all kind of put together in the name of the demo. And so like the kind of abstraction that you get from like wasmCloud SDKs is soon to come. But we're using the WIT bindgen to generate the interfaces for this WebAssembly module. And then we're doing things like creating a messaging broker. And then based on the message that comes in, we're specifically going to be listening for ping. We return a pong, and we end up doing a key value increment call. So all of this is very like base SDK-y. A lot of this is going to be abstracted into the kind of a similar model that we do for wasmCloud now, but it's going to be all wasmCloud specific. But the real point is here, all the interfaces here are not wasmCloud specific, and you're just still able to work in your business logic. Let me zoom in just a little bit. So you can build this using cargo build. You compile to WASI, which is just the other WebAssembly target other than wasm32 unknown. And then we use a pretty, it's a longer command, but you essentially take this WebAssembly module and migrate it to a WebAssembly component, which is in the preview 2 format. And once we do that, we can take a look at the WIT. The WIT is the interface types, the interface that this actually uses. And if we take a look at what this WebAssembly module depends on now, it depends on the wasmCloud messaging types, the wasmCloud key value interface, which just supports like a simple get and set, and a couple other ones that just make things work normally with WebAssembly. But the real point is that all these things that are bundled in, we're essentially saying, hey, I need to be fused with a component for a key value or for HTTP server, and any runtime could provide that. So in order to actually get this, what I'm calling a fused component, to like build these components in together, it's actually this super cool tool called Wasm Builder. And I'm sorry, I'm forgetting exactly who put this together, but this was an awesome tool that also was shown off at the wasm.io conference. I can actually add a couple of components, and let me go ahead and pull this up. Oh yeah, that was right. I can add a few components and actually stitch this together like in a UI. So in components, we have let's start with the WASI ones. We have the key value WASI component, and then we have the messaging component. We have our component that we just built, which was it's called ping pong. You send a message, we'll call that ping pong. And then we have, last but not least, the actor component. This is the wasmCloud actor specific functionality in order to get this to work within wasmCloud. And just note, for the purposes of the demo that I'm following through this README, that this is like all of the base steps and like stitching it together with a UI for fun, but certainly what our goal is to have the tooling very, very similar to the way that you do it now, where you just run wash build an actor. Liam, got your hand up. You have a question?
Peter Hewen over at Fastly developed this tool, and if you are visiting wasmbuilder.app, in the top right, you'll see that there is a GitHub link, and it'll take you right to the repository. Just FYI for anyone watching the call now or later.
Yeah, thank you so much, Liam. I should have pulled that up ahead of time. So let me show you what this looks like to actually, this is such a fun tool. We can drag these components onto the little canvas here. And I'm just going to kind of organize things here. So what we have, the parts that are making up this actor are now our ping pong component, which is just the pure business logic, what you as a developer are going to write for actually running your application. We have the wasmCloud actor component over here, which it will actually take some of the things you're doing in the component and export it in terms of a way that wasmCloud can understand. And then the two standard components here for messaging and key value. And I think I'm going to double check some things, but we can actually, essentially what we're doing here with WebAssembly is hooking up the imports and exports so that all of these types and requirements are matched up. So we hook up messaging to messaging types and producer, because messaging is going to be producing those messages. We hook up the key value component to the ping pong component. And then on the other end, I think we have handler go to handler. I always reference back here to make sure I'm doing it right. Aha, so messaging also goes to messaging types for the wasmCloud actor. And handler is an export that is imported by the wasmCloud actor component. So this composability, when done manually, can be a little verbose, but all this is essentially going to be done by automatic tooling, which is pretty neat. And then the last thing we do is we just say, hey, I need to export this actor's exports. So the wasmCloud environment is going to import them. Then what we can do, we can download this component, and I just call it like used ping pong, something like that. And then I think that's all I'll do. And you can actually add that to the library. You can take a look at this individual WebAssembly component, but you can see here that it has a couple of imports from the host, and then this one actor export, which is what wasmCloud is going to import on the other end. Very kind of WebAssembly primitive style. I can't see the chat, so feel free to just raise your hand if you have a question right now. All right, so now that we're done with that, what we can do is I can actually grab this fused component that we made, and here it is. I'm gonna move this to a more convenient location so we can actually operate on it, and then just rename it really quick. So we have our fused ping pong WebAssembly component. This is pure WASM. It has nothing WASM specific yet, but as you know, in wasmCloud, we actually require you to sign your WebAssembly modules with the claims, the capabilities that it's going to make use of at runtime. And so what I can do is I have my fused ping pong component. I can sign that component with the key value capability, the WASI messaging capability, and then I can give it a name. I'll call it like community call ping pong, something like that. And then, so now we have an actual wasmCloud actor. Let's see. We have an actual wasmCloud actor that's signed with a private and public key pair. And then we have its capabilities. And essentially the reason why we're doing all of this on top of the component model is that these capabilities that you're going to invoke, it could be anywhere in the lattice, it could be distributed across a number of different machines. And so now this WebAssembly component that was built is able to do things in wasmCloud that we're used to with actors, just all with the standard interfaces. So let's go ahead and make this work. So I'm going to go ahead and launch Wash. I'm going to do it with a couple extra, I don't need to do that. All right, I'll go ahead and launch Wash. I'll do Wash up to get wasmCloud running. And then as soon as that launches, we can actually come in and grab our WebAssembly module. So this fused ping pong is the one that I built. And then we can start the WASI messaging NATS provider. And then I'm just going to start our standard wasmCloud KV Redis store. And I think I still have Redis running. Yep. What I can do is I can sub on Pong, which is what the WebAssembly module is going to publish out on. And then I can publish a message to ping. Oh, no. Let's see. I might just need to relink these together. We'll do community call ping pong to wasmCloud. And as soon as we send that ping, we get a response on Pong, which is actually it's formatted like a cloud event, but it's a message coming from inside of that WebAssembly module that is built with WASM components. And so I know that this demo is very like stitching things together, building things with components because it's so early days. We're really proud to have an actual implementation based off of this. But it's really all coming back from this future goal of we're going to be taking away the wasmCloud interfaces that we build and you specifically depend on to build actors and replace them with the WebAssembly standard WIT interfaces for wasmCloud. And this is going to be really awesome from the perspective of building actors because you can actually build WebAssembly modules with components and then bring them to wasmCloud without needing to change that. That's kind of all stitched together by the wasmCloud host. And then there's a couple more implications in terms of our ecosystem, but I'm going to go ahead and pause now after the demo just to give people a chance to ask questions if they'd like. And then I'm going to go into talking about different things in our ecosystem. So does anybody have any questions? Kevin?
I promise I'm not an audience plant. This is a genuine question. How much of the manual stitching together that you're doing for this demo is going to go away over time as more and more tooling becomes available for things like the component model?
Yeah, this is a great question that I probably don't have the best answer to. But the way that I see it is that essentially all of the stitching together that I'm doing manually is going to be abstracted away by tooling. The same way that you don't have to stitch together individual interfaces. The way that I see it is that you would create your WebAssembly module and then essentially declare and build in the wasmCloud interfaces that you want to take advantage of. And then those individual components are automatically pulled down, built into your WebAssembly module, and then you go from there. So essentially how you run cargo build, that's all kind of included. Roman, I think, I don't know if you have a question or more detail that you'd like to add in there, but I think you definitely have would have a well-informed answer for that one.
Yeah, essentially more detail I want to add. So essentially, we would have this tooling which could provide this compatibility layer for wasmCloud right on both sides. But what I'm working on right now is actually removing the need for any of these adapters on these sides. So basically supporting both models where you do have an adapter or where you just have an off-the-shelf component which you may not even have written. It has nothing to do with wasmCloud at all. And you simply sign it, and then you can run it in the new host. So you don't actually need to do any of the stitching at all because all of these interfaces are standard, right? But there are implications to both approaches, right? But it's always going to be, for example, for performance, it would be better to use the interfaces directly rather than through the wasmCloud APIs. But for some purposes, you may want to do that. So it's a pros and cons everywhere.
So Roman, just to maybe rehash that one. So essentially you would build your WebAssembly component using like the language standard tooling, like cargo component build, or you may need to install WASM tools or something like that, but cargo component build or like TinyGo build. And then all you would have to do is the regular step that you do for wasmCloud, which is signing it, and then it's ready to go.
Yeah, so there'll be one vector how you could get stuff into wasmCloud. You could be different vectors, right? And potentially it could even be backwards compatible with what we have today. And one of the reasons why, for example, it could be this way is that we can also benefit from everything happening in bytecode alliance. Like, for example, WASI HTTP is something currently being implemented in wasmTime itself. So a lot of functionality for outgoing and incoming connections, all that we could just benefit from community contributed bytecode alliance thing.
Okay, super cool. Let's see. I saw there was a question in the chat, but Oren, I think you actually won with your hand. If you want to go.
Sure. Would you declare these dependencies in cargo toml exactly or somewhere else?
I think they actually end up coming in the WebAssembly module itself, like at the top of the, let me share my screen really quick. Here at the top of the WebAssembly module itself, we say, hey, generate these interfaces based on this WIT file and in the world ping pong. And so the WIT file actually has the standard interfaces in there. Roman, is that?
Yeah, so I'm actually working on removing the need for any of the WIT interfaces in your actual actor. I am not sure if it's going to work yet today with Bungee functionality, but so far it seems like we should be able to just have simple one crate, like we have already these interfaces, different crates, right? So you would just import from that crate and just implement the interface. So you wouldn't actually need to write any WIT or depend on WIT Bungee directly.
Did that answer your question, Oren?
Yeah.
And then Kevin, I don't know if you had a follow-up there or another question, but.
Yeah, I think just to put another way, when we're working with components, your cargo toml never actually depends on another component. You depend on the interface or the contract. And so there's never actually any tightly coupled dependencies. What Roman was talking about, where there's a crate that you can depend on, it's that's basically a convenience and a way to simplify things. But the underlying principle is that the component model frees us from tightly coupled dependencies, which is has a much bigger impact than most people give it credit for.
Okay, so that's a little clearer, but I guess there is somewhere where you declare the composition of these. It's not within any one of the components, but I guess where would that somewhere be?
Sorry, Roman's got his hand up.
Yeah, so basically there are, so the way that I'm designing it today, right, you could define anywhere you would want, right? So you could just have this WIT directory with your WIT interfaces right next to your actor and just run that to wasmCloud. Or you could import basically those interfaces already generated into nice Rust code from our crate, right? Which are going to be exactly the same interfaces, right? Or maybe there's some other crate you can import with some functionality, but basically somewhere something is going to call with bindgen to generate those bindings for Rust, for example, or Go or whatever else you use, and then you import those Rust bindings from wherever. That's kind of the idea.
Yeah, just as a general note, I feel like in wasmCloud, and we can touch on language support a little bit later, I would have a soft preference for declaring, if we're looking for a standard way to do it across different languages, maybe declaring it, inside of the code, or just like not in the cargo.toml specific format. There's kind of a balance there between doing it the same on every different language or doing it as close to like idiomatic adding in an interface. So I think comparing and contrasting that will be really good just to figure out what feels the best. Taylor.
Yeah, something I want to point out here too, and I know I've talked to Rowan about this before, is the ideal future. Not what we're at right now, but the ideal future is that you grab the interfaces you want to use. You use the WIT bindgen stuff that he's talking about with whatever language you're in. And then we just take your component, automatically glue everything together for you. That's further out, but like that's the ideal, is that these things can be swapped anywhere that has the exact same interfaces. So Right now we do some composition outside because that's just the easiest and best way to do it right now. In the future, I imagine we can get to a better state of that, and that's what we're hoping for. But right now, what's been described is how it works.
Awesome. Yeah, really, really cool to see from and how, we'll essentially, you're basically working on both possibilities. We'll be able to try it out. It's really cool.
Yeah, so
right.
one really cool thing here is that because there are things already implemented by wasmTime, for example, the random number generation, right? So we can actually wrap this standard WASI random interface and implement, for example, the rand RNG trait. And now you can just use all the functionality provided by the rand crate using WASI random, which the host didn't even have to implement because all of that was already provided by wasmTime underneath. Or it could be provided by host as well, right? So there are both possibilities are possible.
It's really cool. Well, I think everybody, what you can expect from this space is that getting a working POC is really exciting. And the newly coming wasmCloud version 62, which we're about to cut another release candidate for later today, has active working support for WebAssembly components. The remainder of the work here really comes from the rest of the wasmCloud ecosystem. So just showing something that works is really the first step and is really exciting. But I want to be candid talking about some of the things that are planning to change over the next couple of months. WASI Preview 2 is planned with WebAssembly components, is planned to fully stable release, I believe, in the fall. I will need, Bailey's not here, it's usually my marker for real deadlines, but that's the last thing I remember. But we essentially have that feature flag turned on in wasmCloud, so it's working now. Talking about what changes in the wasmCloud ecosystem, we'll call out specifically that it's going to be a period of time where we're taking all of our examples that are built with Smithy interfaces and wasmCloud SDKs, and we'll essentially migrate those to be using WebAssembly components instead. From the perspective of anybody who's consuming these examples, it doesn't really change anything. The input and output is still the same. Like if you're using HTTP server, still taking in an HTTP request and returning an HTTP response. It's just how they're built. So really the guides around building actors with WebAssembly components and that new tooling is what will change. This actually should be even lower friction than the way that we build things today. So it's all an improvement. In terms of the capability providers themselves, we have big plans for where we want to move with capability providers, but for now, they'll still be built as native binaries that just interact the same way with a WebAssembly component as they did with, essentially the freestanding actor. And when I say WebAssembly component, I mean a wasmCloud actor, but built with components. In terms of wasmCloud host, there's not really much more that needs to change. wasmCloud hosts for at least for the amount of time that we can foresee are going to support backwards compatible mode of running actors that are built with the current tooling and wasmCloud interfaces and actors that are built with WebAssembly components. It's just the way that they're stitched together. The inputs and outputs are still essentially the same. So at least for the time being, don't expect any huge breaking changes for the actors that currently exist if you've written those or WebAssembly actors for wasmCloud right now. It's worth noting that there will likely be, especially on our road to 1.0 with wasmCloud, there will likely be a point where we segment and ask everybody to build their new WebAssembly modules with components. I think that is a pretty natural step, especially adopting the standards. But I want to mention that all the changes that we're going to require, we're going to try to support backwards compatible things as long as possible. And this is a migration speaking truly selfishly, where we have an entire backend built on wasmCloud at Cosmonic, like we have to do the same migration too. So we're making this as simple as possible is really the goal. Now, lastly, what I want to talk about, which is a really fun one, is language support. The really cool thing with the WebAssembly component model is that all of those components can be written in different languages if you choose. So for wasmCloud, for the wasmCloud specific components that we'll publish, we'll probably write them in Rust now, or continue writing them in Rust. But bringing in these standard interfaces and being able to use WebBindgen actually really opens the door for us to expand language support with wasmCloud. And we've held off on this for a good while due to the effort that it takes to write code gen for a language and continue to handle that in a good way. So we've really bet on rolling with Rust and TinyGo and proving out what this feels like to build actors. But now, and once WebBindgen continues to publish more languages, essentially once you see a language come out in WebBindgen with support, we get that for free with wasmCloud. So that's really exciting. It's all kind of a community effort, which we're really excited about. And we may end up even contributing some of those code gen libraries based on if we wanted to add a specific language. We have experience doing TinyGo, so I think actually Musaka on the Deus Lab side at Microsoft has worked on the TinyGo WebBindgen already and gotten that. So all that's really exciting. All of this is really meant to say that there are some really cool changes coming into the wasmCloud ecosystem that will really help with our mission of decoupling business logic, letting you write in the language of your choice. And we'll be essentially updating you in Slack / on the community call every week on our progress. Probably start a little blog series too on getting this done. Liam, did you have a question / more to say there?
Brooks, let me just ask this another way. Is it accurate to say that for the languages that support components, there's a JavaScript tool out of Shopify, there's a Rust component tool, that those languages are now supported on top of the next version of wasmCloud?
That's my understanding. I think that there will always be a couple things that we're going to want to run tests for. Like before we say, boom, we have JavaScript component support, we're going to want to build something with JavaScript components and take a look. But that's the beauty of composing components. The language that you're building it in kind of sits in the middle of what interfaces with the outside world. It's really cool. Yeah.
This really seems like a flattening technology. If you look at what folks have been doing for the last 6 months is runtime specific language SDKs, and it feels like all that just goes right away and everybody just starts to interchange components, which is stupid powerful.
Yeah, super exciting. All right, I did a good bit of talking there. We do have another exciting demo for the second third of this call. Any quick questions on that stuff before we move on? We'll continue to stall long enough to give Kevin co-host. All right. Then we'll kind of wrap up that component section as usual. Feel free to have more questions in the comments or into Slack. We'll obviously continue talking about this. But Kevin, I won't spoil anything. Go ahead and take it away.
All right, let's see if I can share it without breaking anything. Let's see here. All right. I'm assuming you're looking at my at a GitHub page.
Yep.
Okay.
You might want to zoom in one step or so, but it looks good.
All right. So a little bit of background before I start getting into the details. I think it's important to remember that wasmCloud is more than just an application deployment target. It's a foundation that you can use to build other products or other frameworks. And as Brooks mentioned, you know, the entire Cosmonic backend runs on wasmCloud. And so one of the things that we built on Cosmonic in order to make that happen is an event sourcing framework. And so we refer to this as an opinionated event sourcing framework. So there are some lines that we draw in the sand that we won't violate, and there are some extra rules in there. And I've got one of my favorite quotes here on the page, which is constraints liberate and liberties constrain. This is sort of the guiding philosophy behind some of the opinions that are baked into this framework. As a quick recap, in case people aren't really all that familiar with what event sourcing is or why you might want to do it, an event sourced application is an application where its state is a derivation of events that have occurred in the past. Put in other ways, it's basically applying functions across an event stream. And the components that sit inside an event sourced application are aggregates, which represent instances of entities. And when I say entity here, I'm referring closely to the domain-driven design definition of entity. Aggregates receive commands, they validate the commands, and then in response, they emit events to the event stream. They handle incoming events, and that's what is used to modify the internal aggregate state. And in the sample I'm going to show, I'll illustrate how that applies to things like maintaining a bank account ledger in a banking app. Another element, another building block of event sourcing applications is a projector. Projectors are the things that build a read model. And if you're not familiar with a read model, you can Google things like CQRS and read models, or even think phrases like materialized views. But the short version is that a projector takes incoming events and generates views that are optimized for read model. So rather than in the banking example that I'll show, rather than having a bunch of different SQL tables that you then have to join on demand every time a user queries, a read model might be a single blob inside a document-oriented database where the contents is the entire ledger, or the contents is just the current balance. So it's optimized for being able to predict what information users are going to need without having to actually do long, complex queries for it. Another element that I'm not going to talk about too much here is a process manager. Process managers are the things that coordinate long-running processes in an event-sourced application. And in the bank account example, that's we use an interbank transfer, which requires multiple commands and multiple events to finish. And then finally, there are generic or stateless event handlers. So these are the things that you use to perform your application IO. So things that you might use to take an event out of your event source system and convert that into an email that gets sent to a customer, and so on. And all of these components I'm going to be discussing at my upcoming KubeCon presentation, where I'm going to talk about event sourcing and then also get into more detail on the concordance framework that I'm talking about now. So I can't tell if there are any questions right now, but I'll keep going. Can you see the tab that I just switched to, the wasmCloud dashboard?
Yep, looks good.
So this is what it might look like if you had a small application running using concordance. So we have the various components that represent the fundamental building blocks of an event source application. So I have a bank account projector that's responsible for building the balance as well as the ledger. I have a transfer process manager that, like I mentioned a few minutes ago, that does long-running bank transfer processes. And then finally, I have the bank account aggregate, which is responsible for validating commands and then emitting events. And you'll see that the aggregate does things like make sure that if the command is to withdraw $200, that you have at least $200 in your bank account. And there's a whole bunch of stuff that I could go into maybe after the demo on, why we might choose to build an application with event sourcing and things like that. But I'm going to get to the demo as soon as I can here. So I'll stop that. See if I can find. Demo here. Okay, I'm sharing a tab in my terminal. Can everybody see what it looks like? So I'm in a directory called scripts.
Yep, that looks good.
Okay, wow, I actually got the spinning beach ball trying to zoom in, so that's weird. So I have this application running, and our concordance provider runs on top of NATS. So you'll see that our durable event stream is based on NATS Jetstream, and the aggregate and process manager state are managed as NATS key value buckets. So all of this event sourcing stuff sits on top of NATS. So if you're using wasmCloud, you basically already have NATS sort of for free. So there's no extra infrastructure that you need for this. In the demo that I'm running, the bank account projector is using Redis. So just to show that it's still, even though we're in an application framework like Concordance, we still have the choice of providers like we normally do, so that the projector can be written against the key value contract and still swap between different implementations. So in an event sourced application, what you would normally do is Concordance is open source. I was on the GitHub page for it a second ago. I'll make sure that we drop some links in there in the chat later. So this is all open source. Let's see, where was I? I'm trying to remember where I was here. So yeah, so we would normally feed commands into an event source domain or application. So in a bank account demo, I've got this scenario here where I'm submitting a create account command, and then I submit 2 deposits and then a withdrawal. And what we'll see here is that the aggregate is going to handle all of these commands. It's going to spit out the corresponding events, and then the projector will deal with creating all of the views that I need. And this typically goes by pretty fast. So there, I just dumped in those 4 commands, and I've used NATS to query the value of this particular key value bucket, which is the aggregate state. And so you can see that my aggregate has a balance of 6,000. And then here's some of the other details on the account. And we can see how that all took place. So I have 2 streams, commands and events. Commands is input. Events is sort of the internal flow. And commands is a work dispatch. So as soon as a command is processed, it disappears from the stream. But because event sourcing is based on a durable and immutable event log, we don't remove events. So I can actually view the events that are in my stream. And these are cloud events in JSON format. So everything in this stream is not only something that developers can read, but is also processable by anything that can read JSON. And these days, that's pretty much everything. So you can see that the first event in here was account created, then I have funds deposited, another funds deposited, and then finally funds withdrawn. And you saw the aggregate state contain the aggregate state contains the current balance and everything that the aggregate needs to validate incoming commands. But like I mentioned, we also need to be able to provide consumers, so whether that's an API or a UI client or something else, it needs to be able to access the read model. And so in this case, the read model is in Redis. So pay no attention to the counters. Those are from our other KV counter sample that I think everybody in Cosmonic probably has KV counters running on their machines at all times. So if I just want the balance of my account, which is a pretty common query, and I want to be able to retrieve that in big O one time, so fixed cost. So you can see that my balance is 6,000. But I can also do, assuming this works, I can get the ledger for this. There we go. And so the ledger for this shows the account number, and it's a list of ledger lines. And one of the interesting things about like the banking ledger model is that there's an effective balance at the end of every transaction. So I ran all of this through with just the simple commands, and you can see the effective balance after the initial deposit was 4,000, then 7,000, then 8,000, and then finally after the 2,000 withdrawal, that's the effective balance. And so I have two different read models optimized for two different consumers for two different purposes, and those are generated immediately upon receipt of the event. So, like I said, I don't have to do a SQL join. And I'm not going to demo it right now because it's a little dangerous. I haven't tried it yet. Is if I wanted to do replay, what I would do is I would delete one of these consumers and then add it back. And then what would happen is the concordance capability provider would pull that data, and since it was a new consumer, it would point at the beginning, so it would essentially just rerun all of those events into that aggregate or projector or whatever. So I would use that if I needed to change the internal state of an aggregate. I'd blow away the state and replay from the beginning. If I decided to change how I'm generating this ledger format, blow away the state, replay from the beginning, and I'm good to go. And replay is also how we can do things like disaster recovery and so on. I'm going to stop sharing here, and then I'm going to see if I can share my VS Code, so you can see what a event source component looks like. Let's make this a few hundred times bigger. All right, so like I said, every one of these fundamental event sourcing building blocks is a wasmCloud actor, but it's also a wasmCloud actor that has a special contract that's part of concordance. So what you can see here is in the projector is I've got apply stateless event, which is part of the contract. And then I do a big match on the event type. And you see here, I've got a comment where in phase 2, which is after KubeCon, instead of having to build the match statement myself, the code will generate the internal match statement, and all I have to do is supply a strongly typed event application function. So all of the serialization and stuff would be taken care of for me. But for now, I have to do a match. And so inside the store, you know, to generate these read models, all I'm really doing is using the pre-existing wasmCloud key value contract. And so I'm, you know, writing an account ledger and writing a balance, which is, where do I put the balance here? There's the balance. I just do a key value set on the balance key with the new data, and there we go. So there are a couple of really interesting points. I know I'm running low on time, but a couple of really interesting points that are mostly enforced with opinions here. And that is, there are no side effects allowed from an aggregate, and there are no side effects allowed from a process manager. Process managers take in events and emit commands. Aggregates take in commands and events and emit events. And so those things are what you might call purely functional or just pure. And then the side effects are all explicitly managed in special stateless handlers called either projectors or notifiers or gateways. And all of the plumbing for this is managed for you. So what's another interesting part about this is that if you build your application using concordance, not only do you get event sourcing for free, but you still get all of the wasmCloud functionality for free. So you can run these actors spread out across any number of disparate infrastructures running at any scale you want, and all of that stuff still comes for free. And then, you know, you get all of the other stuff for free, like durable event storage and replays and everything else. There are, after KubeCon, I'm going to build a much larger event sourcing application to show off some of these extra features. But yeah, for now, this is all still in experimental mode. And then after KubeCon, I'm going to be converting the experimental stuff into less experimental stuff. And so it'll have more more focus on a smooth and ergonomic developer experience, better documentation, better tooling. We're thinking about integrating with the wash command line and so on. And that's all I've got for now. Trying to get in there under the 2 o'clock line. Yeah, Taylor, I think, was up first.
Yeah, I just wanted to point out here something that Kevin kind of mentioned, but is kind of really critical here, especially for anyone watching the stream and wondering why this really matters, even if you don't care about event sourcing. This is exactly why we love wasmCloud and why we've all been dedicated to this project for so long. You'll notice this isn't like a FAS solution or serverless. This is an like entirely like robust, used in production architecture, in addition to the other ones we've shown you, like microservice type architectures and more monolith type applications. Like this is all done, like this is an actual full like event sourcing thing done inside of wasmCloud. That's not something you're able to do with the with a lot of things with WebAssembly right now is anything more than that kind of functions as a service type of thing. So I just want to point out, like, this is really dialing in and showing like you can build all sorts of architectures on top of wasmCloud right now.
Brooks, you had your hand up and then it vanished.
Hopefully I did have my hand up. Yeah, I was gonna say something, but I think I would rather yield my time if anybody else had a question for the last minute or so, and then I'll just do an outro.
I think Oren's got a question.
Yeah, do it.
I have a few, but I don't know if you want to like plan around the time more so than my questions. I could ask them like at some other place.
We'll still plan to end off here. It's 2 now. If you wanted to fire one off, and then we can continue the discussion in Slack. Let's go with that, just to respect everybody's time.
Yeah, people can also stay around after, so we can probably tidy up Brooks and then do the normal stay around after. And anyone who has questions, we can talk some more.
Okay. Yeah, I'll go ahead and do that. Well, thank you everybody for coming to the stream today. Kevin, the only thing I was going to say with my hand up is really like, I really look forward to the some of the documentation around this and like comparing how you may build this bank account model without event sourcing and then with event sourcing Celium. But this is really cool. Thanks everybody for coming today. We'll pick up next week with more exciting stuff. I'm going to stop the stream, but we can keep hanging out and talking about